All right, so this is example 2f, okay? So f of 3x, we're plugging in 3x, but every time we see an x, what's 3x squared? 9x squared, okay. That is 9x squared, so negative 3, drop it down. 9x squared plus 6x, right class? Negative 3 times 9x squared is now negative 27x squared plus 6x. Pretty sure you got this. Good. All right. F, G. Where are we, what alphabet are we stopping? H. Woo. I know, right? All right, McKinley, can you read me what G says? Because I don't have it anymore here.
F, x plus 3.
X plus 3, great. Is it very similar? Yes, except every time I see an x now, I will plug in x plus 3. Let's do it. Okay, so negative 3, I see an x, I'm going to leave that blank. I see an x, I'm going to leave that blank. And now I'm just going to plug in x plus 3. You're going to need to simplify. Okay, so you and your partner, or try it out for yourself first. Simplify that out. Once you have an answer, compare with your team. It's okay to be wrong. That's why we are learning. As long as we correct our mistakes, oh yeah. Hey, 4 donuts. We're trying to give you an answer.
No way.
All right, I'm gonna write Payne's answer back here, and then because I need to. All right, Payne, what's your final answer?
Do you want it factored or do you just want it regular?
Final answer.
Okay.
Okay. You don't need to factor it if that's what you're. Yeah.
Negative 3x squared minus 16x minus 20.
Wait, minus 16x like that.
Yeah.
Minus 21. Okay, I'm not sure if he's right yet, so he doesn't get a donut. That's right. Let's work it out. Here we go. Oh, you want to? You have something different? No. Yes. No. I do. Okay. So you might get the donuts. You're right. Let me write yours down a different color. Okay. All right. What's your answer?
I have negative 3x squared plus 2x
Plus 2x. Like that. Minus 21? Who else has something different? Yep. Let me get a different color. Hold on. Rainbow. Okay. What's yours?
Negative 3x squared plus 2x plus 75.
Plus 2x plus 75. Like that?
Yeah.
All right. Let me work it out. I don't know yet, so let's see. Donuts goes to negative 3 times. I make lots and lots of silly mistakes, so I write this out twice. Okay? Then now I'm just going to distribute, so that's 2x plus 6. I'm going to FOIL that out, so negative 3 times, that's x squared. In the middle, I should have 6x. Right, class? Mm-hmm. So now I have that. I'm going to distribute the negative throughout, so here we go. This is going to be a negative 3x squared. So we're all correct on that piece. That's going to be a minus 18x, minus 27. Drop these two things down. Can I combine like terms?
Yes.
All right. What is that? Negative 16x. Is that one? Yeah? And then this and that is what? So is that still good?
Yep.
So is that good?
Yep.
Who won? Is that Payne?
Yeah.
Oh! All right, Payne. Donuts or bagel?
I know, right?
I have donuts or bagel.
Donut.
Donuts, right. I know, it's all fun, guys. I got the cream filling one or non-cream filling one. Some chocolate looking thing. I'm not a donut, person, or I'm not a, this or this. You have stuff in it. I don't know if this is.
I'll take the chocolate.
The next person. We have two more. Okay. And then we got bagels. So, okay. It's like a bribery, right? Or at least try to keep you up. Yes, question.
So the way I did it, I took x+3 and then I just quantified it out and then I just multiplied it by -3 after that. Did that still work?
So did you multiply like that right there?
No, I did x+3 multiplied by x+3
Uh-huh.
and then factored that out and then I.
But if you factor out, don't you get this back?
Yes, and then I took that huge factor and multiplied it by -3.
Right, but if you have this and you factor, then you go a step backwards.
I don't think so. I got the same answer. I'm just wondering if it's more efficient.
So this is where you were, right? When you multiply it out?
Yes.
When you factor it out, wouldn't you get these two? That's my question, I guess.
Yeah.
Right, but then what do you do after that?
That huge.
Multiply that?
Yes.
Weird thing will work too. Then then that means you can skip this step.
Yeah.
Because you're going forward and then backward and then, yep. That's okay. So you can do that.
Okay.
And then do those two.
Yeah.
Yep, totally. All right. I'm gonna, so we have fixed the right answer, right class? All right. Last letter on this one, G, H is the last one, am I right? Okay. H, here we go. Let's handle this. Nathan, can you just read me what H wants us to do?
F parentheses x plus h, parentheses minus f of x, all over h, and h does not equal 0.
Great. Easy?
No.
Okay. In your book, you're going to have this as one of the homework, just not tonight, but tomorrow. In your book, they call this the difference of quotient. Okay. Difference of quotient. Now, the word difference in mathematics means what? Subtraction. Do you see the subtraction in this? Yes. Quotient means divide. So you're just doing one problem with two things in it. This right here, it's just saying that h can never ever be 0 because h is in the denominator. You don't really use that at all in terms of evaluating, okay? Well, the first thing you're going to do is evaluate, and they get yellow. Evaluate this. Do we kind of know how to do that? Did we do something very similar to that? Yeah, instead of h, we did 3, right, in letter G. So in this one, we do exactly the same thing, except we keep h as h. So we're going to break this down in pieces. So the first thing I'm going to ask you to evaluate is this right here. And similarly, every time I see an x, I'm just going to put in, yep, so -3 quantity square plus 2 quantity, okay? This is where I put in what? X plus h. Now, if you make lots and lots of silly mistakes like I normally do, then write it out twice and multiply it out cautiously, okay? Okay, so that's 2x plus 2h. Okay, do me a favor and multiply that out. Let me know what you end up with, that underscore right there, okay? Maddie?
X squared plus 2xh plus h squared.
X squared plus 2xh plus h squared. I'm going to wait to see if you can confirm that for me. So, is that confirmed by you guys? How do you mean that? Is that right? Yeah. Bless you. X squared plus xh plus h squared. All right, now can I distribute the negative 3? Yes. Perfect. So we are going to end up with negative 3x squared minus what? 6xh minus 3h squared. And drop these two things down. Check to see if you can combine anything. Can we combine anything? No, nothing. Nothing's the same. Nothing's the same. So keep it as is. Okay, so now we have the first piece. Can someone tell me, do we know what this is at all? That green piece. F of x. What is it? Yeah, right? It was given to us. Remember, it's the same f of x the entire time. So can I just put those together right now? So now, I'm just going to copy that over. I know it's a long one. Okay, so negative 3x squared minus 6xh minus 3h squared plus 2x plus 2h. Okay, I'm going to subtract f of x. And you told me f of x was negative 3x squared plus 2x. Why is it that I'm using the quantity? Why do I need to put parentheses around f of x? Very good. What if I don't put the parentheses? What is the incorrect piece of this if I don't put parentheses? What's going to be wrong? Yeah, would this positive 2 get distributed with this negative? No. So that's why when you're subtracting a polynomial that makes more than one term, you want to put parentheses. Now, so I subtracted it. All of this has to be divisible by? All of this has to be divisible by what? H. All right. Let's distribute the negative and then work it out slowly, okay? So negative 3x squared stays, minus 6xh stays, minus 3h squared stays, plus 2x, plus 2h, minus and a minus is now a? Positive 3x squared. A negative and a positive is now a? Negative 2x. All of it is divisible by h. Okay, you guys have to tell me whether we can cancel anything.
Yeah.
Yes, what are we going to cancel? X squared, Anything else? 2x. Great. Look, it's getting smaller, see? All right. Negative 6xh minus 3h squared plus 2h, all divisible by h. Anything else I can do? Anything I can simplify?
You can factor out the h and then just
Yeah. Isn't the top has something in common? Yeah, there's a reason why we review factors for like 3-4 days, right? Because there's a lot of factoring. All right. Factor out the h. You have negative 6x minus what? 3h plus 2. All of that is divisible by h. Now the h and the h will cancel. Final answer is negative 6x minus 3h plus 2. And that's it. This is 100% will be on all quizzes and all tests for a very long time. Like over multiple quiz and tests. Okay. So if I were you, I'd write test question, you know, star it, circle it, highlight it. I don't know what you do to get your attention. But all right, one last example and we can call it a day. I can go back to my notes now because I'm pretty sure I have enough room under 3. Okay. Okay, example 3. Jenna O, can you help me read the directions, please? Perfect. Okay. Down the bottom, I know I should put that at the top, but down the bottom, there's this box. It says finding the domain of a function defined by an equation. Step 1. Kyle N. Can you help me read step 1, please, Kyle?
Start with the domain as a set of real numbers.
Good. So it says, hey, whatever equation I give you, just write all reals. Okay? And then it goes on from here. Step 2. Julia K., can you help me read step 2, please?
Yeah, if the equation has a denominator, it's the only one that can be written.
All right. So far, so good? Okay, so if it doesn't have a denominator, Your domain is? Step 1 said the domain is? All reals. Okay. Only do step 2 if there's a denominator. And then there's one more, okay? Nick B, can you help the last read 3? Where's Nick B, since I don't know? We don't have a Nick B anymore? Oh. Okay, how about Haley K? Can you help me read 3?
If the equation has a radical of even index, exclude any numbers that cause the expression inside the radical to be negative.
All right, we have to exclude some more if it has what? What does it have? A radical. Then I need to exclude numbers that makes it what? Negative. Okay, so we have 3 different examples here. Let's go through the motion. We're going to follow it. A. Does it have a radical or a denominator? Yes. What does it have? A denominator. What is it that we can never ever have in the denominator? 0. So we need to find x that we need to exclude. So what you need to do is take your denominator. In this case, is x squared minus 2x minus 3. We are going to set it equal to 0. The reason that we're trying to find the x that makes it 0, so we can say, I need to exclude them, okay? Do we know how to factor? Great, can you factor that for me? Huh? Oh, give me a second, I'm gonna give them this chance. Since I have like 2 more donuts. Okay. For this donut, who can tell me what to do from this on out? We're gonna pick a girl.
Okay, you want to factor it?
Tell me what the factors are, and then how to solve. What are the factors? What are the factors?
X minus 3, x plus 1.
Okay. Now, how do you solve it from here? How do you solve it from here?
You subtract, or no? I forgot.
You get the donuts anyway. We're trying. I'm not gonna say no. Okay. All right, last donut. You need to tell me. Tell me how to solve.
Just for x? Set x minus 3 equals 0.
Good.
And then add 3, and then x equals 3, and then set x plus 1 equals 0. And subtract 1, x equals negative 1.
Thank you. And then x plus 1 equals to 0, x equals to negative 1. Okay. Now my question is, guys, is that the domain? Is the domain 3 and negative 1? No. Remember, the problem is that the domain should be what? All reals. So here we go, domain. You're going to start with all reals because it has a denominator. You're going to say all reals excluding what? That's right. Okay. All right, for a bagel, who can give me the domain for number 2? Oh no, let it be. For a bagel, because that's all I have left. Bryce.
Okay, so you factor to be x plus 3 and then x minus 3, and you end up with negative 3 and 3 as your exclude zeros.
Is Bryce right? Let's read the stages again. Okay, raise your hand. Maddie, for a bagel.
I have to read or tell you.
Oh no, just tell me what the answer is. And
Oh,
we'll
it's all real numbers.
It's all real numbers. Maddie, why?
Well, because it's not a fraction or under that, so it's just a constant line, or in this case, it's a curved line.
Right.
It's on forever.
Right? Oh. Okay, so Maddie's right. Look at the 3 steps. The first one, it says start with the domain being what? And then you go on. If and only if it has a or a. This one does not have anything. So what's the domain? All right, Maddie, you get a bagel. Woo! Okay. Last one. Is the domain all reals? No. What does it have? It does. What are you going to do with it? It has a radical. What is it that you can't have under the radical? Negative. Can I have 0? What's square root of 0? 0. Okay. So that's what we're doing. All right. So, I don't know. Gosh, food and okay. So, because it's very similar to letter A, you're gonna take what's under the radical and set it equal to 0. But unlike letter A, you can have that value. Does that make sense? In letter A, you cannot have it because it's a denominator. In the radical, we're going to do the same thing. We're going to set what's under the radical equal to 0. And then we're going to keep that value. Okay, so what's under the radical?
3 minus 2x.
Right. Okay, equal to 0. We're going to solve for it. So minus the 3 from both sides. Divide both sides by?
-2.
All right, so x is now a positive 3 over 2. Is that my domain? The domain is just one value, x equals to 3 over 2.
No.
No. This is really difficult. Or another bagel. Look at tell me what the domain is.
The domain is all real numbers less than 1.5.
All real numbers less than 1.5. I'm just gonna box it up. Next color, and the winner gets
X is less than or greater to 1.5.
X is less than, and I'm sorry, one more time. Less than what?
Less than or greater to.
How does that work?
Or equal to.
Oh, okay. Yeah, I know. It's hard for me to write. So okay, sorry. Less than or equal to 1.5, like that. Yeah. Anyone else? Sigish? Yep. Another color? Yep. Paint? No. I'm just taking all of your guesses and then who wins, right?
Yes. X is greater than or equal to 1.5.
Now keep in mind, you can't have negative and then, Ming-Chun? Where am I?
Is it x is greater than 1.5?
All right. Huh? X is equal to 1.5?
I know, but
All right, all the different guesses. That, by the way, that's all the possibilities. Okay. 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 So instead of guesses, this is what you have to do. You solve for the x value. Put it on the number line. Okay. This is what x. Okay. This is all the x values right there. That's 3 over 2, 1.5. A closed circle means I can have it in the domain, right? It's inclusive. An open circle means no, I can't have it. So at 3/2, what happened when I plug in 3/2 in this? What would come out of it? 0. Can I have a radical of 0? Yeah, so technically, can I have this value? Yes. Right, I'm going to do a closed circle. Okay? Now, you have two possibilities. It's either less than or equal to or greater than and equal to. So can I cross those out? Right? Yes or no? This is what you know for sure. Pick some really outrageous large numbers on both sides and plug it in and just test to see it's positive or negative. 100. Plug it in. Is under the radical positive or negative? Positive, negative. Negative, right? So can I have negative things on that side? Yes or no? No. Let's plug in negative numbers, like some outrageous negative big number. Negative 2 times negative 100 is negative positive. And then add 3. It's positive. So who's the winner? Okay, so domain is the blue one. So cross out everything else. Okay. Who is the blue one? All right, bagel. Yeah. I have plain and sesame. What would you like?
That's what we did last year in class, like, we had a finals.
Okay, bye, kids.